In this video, I'm going to show how to differentiate x squared from first principle. Normally, we use power rule to differentiate a function in the form of x to the power of n. So the derivative of x squared is 2x and derivative of x to the power of n is nx to the power of n minus 1. However, now suppose we don't know the power rule and we have to calculate the derivative of x squared. So we know derivative as being a gradient at some point a with coordinate xy of a function. So now let's draw the graph and try to work out the gradient at point A. This is the graph of x squared with x and y axis, and the tangent is drawn at point A. Let delta x with a small increment made in x, and as a result delta y with a small increment made in y. So another point that lies on the tangent is a1 with coordinates x plus delta x and y plus delta y. So now our equation y equals to x squared becomes y plus delta y equals to x plus delta x to the whole square. Now let's make delta y the subject and substitute y equals to x squared into our function and divide both sides by delta x. Here delta x tends to 0. By applying limits we have dy by dx as our subject. Now we can solve this algebraic equation by opening numerator, which is in the form a square minus b square, and then delta x in the numerator cancels out with the delta x in the denominator. Now our equation becomes valid to apply the limit. Since delta x tends to 0, we are now only left with 2x. This is how we calculate the derivative of x squared using first principle.